Hi everyone, welcome back to another video. Today we're going to take a look at the circle geometry or analytical geometry question from this paper. So the question says, in the diagram below, the circle with center C touches the y-axis at A, and A is a straight line with equation, a straight line with equation 3x plus 4y plus 7 equals 0, cuts the circle at B and D. Question 4.1.1, determine the equation of the tangent to the circle at B. All right, so to work out the equation of that tangent, if I look at the tangent, I can see that this tangent is a straight line, and so it's going to follow the format of y equals mx plus c, or mx plus b, whatever you want to call it. Now, to work out the gradient of that line, we need 2 points, or m. However, we don't know 2 points on that line. Instead, if we look at this line DB, we can work out the gradient of that line and then use the property of the radius and tangent being perpendicular to work out the gradient of the line in green. So first, let's work out the gradient of that line DB. So we have the equation of the line DB, and so then we can just rearrange it and work out the gradient. So that line DB is 3x plus 4y plus 7 equals 0. Now we just need to do some rearranging because we want it in the format y equals mx plus c. So let's take everything over except the 4y. So 4y is equal to minus 3x minus 7. Now again, we just need to divide everything by 4. So y is equal to minus 3 over 4x minus 7 over 4. So the gradient of this line DB is minus 3 over 4. So the gradient of the line DB multiplied by the gradient of the line, let's just call it the tangent, is going to equal to minus 1. And that's because the radius is perpendicular to the tangent. So minus 3 over 4 times the gradient of the tangent is equal to minus 1. Now divide everything by minus 3 over 4, you're going to get the gradient of the tangent is going to equal 4 over 3. Now that we know the equation, or rather we know the gradient, and we know a point on that line, we can use the formula y minus y1 is equal to m into x minus x1 to work out the equation of the line. So we'll substitute point B, since it's on the tangent, minus 1 and minus 1. So y plus 1 is equal to 4 over 3 into x plus 1. Then y is equal to 4 over 3x plus 4 over 3 minus 1. Y is equal to 4 over 3x plus 1 over 3. And that's our equation. Okay, now let's look at question 4.1.2. 4.1.2 reads, determine the equation of the circle in the form x minus a all squared plus y minus b all squared equals r squared. So we want to figure out what the coordinates of the center is, and we also need to figure out what the radius is. So one of the first things I notice here is that this point A is touching the y-axis, right? And so this line CA represents my radius, but also since it is parallel to the x-axis, I can say that the coordinate for C is going to be some value, let's call that A, and the y value is going to be 2. So we can write the equation as x minus a all squared plus y minus 2 all squared equals r squared. Now what we can do is we can actually figure out the coordinate for A. Because since the line C, well, the point C lies on the line DB, if I substitute y equals 2 in the equation of the line, I can actually get the x coordinate. So I can say that the equation of the line DB, so DB is y equals, we worked that out, it's minus 3 over 4 x minus 7 over 4. We know the y value, we want the x value. So 2 is equal to minus 3 over 4 x minus 7 over 4. And now I can take this across and then multiply. So 2 plus 7 over 4 is equal to minus 3 over 4x. Then divide both sides by minus 3 over 4. That's going to cancel. And so I'm going to get x is equal to negative 5. So I got my coordinate. So A is negative 5. Now, I don't need to do anything fancy to work out the radius, because again, since this CA is parallel, I can actually figure out the radius. So if this is negative 5 and it goes up to 0, that means that distance, or that length, must be 5. So I can write out my formula. My formula is going to be x plus, well, x minus 5 is x plus 5 all squared plus y minus 2 all squared equals 5 squared. Now, they want it, yeah, so that's r squared, that's fine, that's correct. Now 4.1.3, determine the coordinates of the image of B after reflection of the circle in the line y equals 2. So in other words, what they are doing here is they are reflecting this entire circle on this line. So let's draw the line in y equals 2. Y equals 2 is this line right here. So y equals 2. So what's going to happen? Basically, if they are reflecting it on this line, the distance from B to this point will be the same distance from B to its new point. Let's call it B prime. I'm just drawing it here. I don't really know if it's going to be there. I mean, it could be somewhere around there. So if I look at what is the distance from here to here, the distance from here to here is, it's going from minus 1 to 2. That's 3 units up. That means from here to the new point, it must be 3 units as well. So if I'm at 2 and I'm going 3 units up, then the new y value is going to be 5. The x value is not going to change. It's still going to lie on that same dotted line. The x value is minus 1. So the x value is going to remain as minus 1. And so the new coordinate is going to be minus 1 and 5. Now let's take a look at the next part of this question. The next question. Question 4.2. A circle with equation x squared minus 4x plus y squared plus 6y minus 51 is equal to 0. and it's drawn on a Cartesian plane. 4.2.1 says determine the coordinates of the center of the circle and its length of its radius. Now to do this, we need to complete the square. So question 4.1 or 4.2.1, I'm going to first transpose this. I'm going to take that over. So I'm going to have 51 on this side. So my equation is going to be x squared minus 4x. Then I'm going to add half of minus 4. And I'm going to square it. Then plus y squared plus 6y. Then I'm going to add half of 6 and I'm going to square it. And that's equal to, the 51 is on the side. And I'm going to add this minus 4 over 2 all squared. And I'm going to add the 6 over 2 all squared. Now I can complete my square. This is going to be x. There's a minus here, so I'm going to put a minus here. Then this simplifies to minus 4 over 2 is minus 2. Minus 2 squared is 4. The square root of 4 is 2. So it's going to be x minus 2 all squared. Then plus, here I'm going to have y. There's a plus here, so I'm going to put a plus here. 6 over 2 is 3. 3 squared is 9. The square root of 9 is 3. So y plus 3 all squared. And that's equal to 51 plus, as I said, this simplifies to 4. And then this simplifies to 9. So x minus 2 all squared plus y plus 3 all squared is equal to 51 plus 4, 55, 55 plus 9, 64. So if they want the center, so the coordinates of the center is going to be 2 and minus 3. My radius is going to be the square root of 64, which is 8. Now, question 4.2.2. Another circle with the equation x squared plus y squared equals r squared is drawn in the same Cartesian plane and touches the circle with the equation that we just did internally. Calculate the value of r. Give your answer to 2 decimal places or 2 decimal digits. Okay, so what I'm going to do is I want to just sketch this out just to have a visual representation of what's going on. So if this is my Cartesian plane, right, that's x, that's y. Now this is going to be a sketch, so it's not going to be entirely accurate. That's 1, that's 2, that's minus 1, that's minus 2, that's minus 3. My center is here. Then I have a radius of 8, so it's going to be quite a large circle. I'm just going to draw it as best I can here. Okay, maybe not ideal, but I think that's good enough, I guess. And now we have another circle. Let's make this slightly bigger. And the other circle has, or is x squared plus y squared. So x squared plus y squared, this tells me that the center is the origin. So that other circle has a center that's in the origin and is something that's not ideal. Let's just draw it. It's not ideal, but I think makes the point. Okay, and so they want to know what is the value of r. So they want to know what is the radius going to be. Okay, so what we can do first is, since the center is the center, well, the new circle has a center at the origin, we can actually work out the distance from the center to this center, right? And so what we can do is, if we complete a triangle here, that's 90 degrees, this length, we're just interested in the actual length, that length is 3, that length is 2. So if we use Pythagoras, we can work out the length of that, the hypotenuse. That's 2 and that's 3. The hypotenuse is going to be the square root of 2 squared plus 3 squared. My hypotenuse is going to be the square root of 4 plus 9. My hypotenuse is going to be the square root of 13. Now, why do we need this? Why is this even necessary? So let's look at a bit of theory here. Suppose I have a circle, right? And here's the center of my circle. And I have a new circle that touches this red circle internally, like this. Now let me move the circle slightly, like so. And the center of that circle is here. So what we can do, let's do some labeling. If this is R, that's going to be the radius of my big circle. And this is R here. Let's call this, let's call that R prime. And the distance between the centers, let's call that D. We can get an equation. And that equation says that R, this red R, the radius of my big circle, is actually going to be equal to the distance between the centers plus the radius of the smaller circle, so R prime. So we can use this to solve for R. So in our example, let's apply it here. So the radius of my big circle, which is 8, we worked that out, is equal to the distance between the centers, which we worked out now is square root 13, plus R prime, which is the length of the radius that we're interested in. So plus R prime. And now all we need to do is we need to transpose. So 8 minus the square root of 13 is equal to R prime, which is the length over here. That's the length of the radius that we want. And so we just calculate this and we get 4,39, and that's our R prime. That is the length of our radius of the small circle. So answer here is 4,39. That's it. Thanks so much for watching, everyone. Don't forget to like, share, and subscribe. And if there's something specific you want me to do, specific paper, question, do let me know in the comment section below. And I'll see you in the next one. Bye-bye.